Hello, folks. We're back, and I'm sorry about the technical difficulties with Miss Lineski, and but she really wishes she could have still been here to finish out the video. By the time I rebooted the computer, it was just way too late to carry on. Anyhow, so we're back, or I'm back, and let's finish up this problem. So we should first figure out what the rational roots are that we want to check, and we're going to use the P over Q method, where the P value was equal to 8, and the Q value was equal to 1. So our possible rational roots are all the factors of 8, plus and minus, all over the factors of Q, which is just 1. So because Q has no coefficient except for 1, it makes the problem extremely easy in terms of a rational root check. So our factors are basically plus or minus 8 to check, plus or minus 4, plus or minus 2, plus or minus 1. Now, in the event that we start checking these roots, and you find that you see that the signs alternate, you would know you're at the lower bound. And if you saw that the signs were all the same, then you would know that you're at the upper bound. So that's something you want to keep in mind when you're working through looking for the rational roots. But in this problem here, we're asked to verify if the roots exist within the boundaries from -2 to 5. So let's start the synthetic division by checking -2 first, and I'll put the coefficients down. And when I go through the synthetic division with -2, you can see I'm just going slowly to check my work. You can see that here at -2 we have an alternation of signs, which means that -2 would be a lower bound on the root, on the polynomial. And so now I'll check 5, and I'll use the same coefficients. And here I have 26 times 5, which will be 130. So I'll be at 138. So this clearly tells that -2 is the lower bound, and that 5 is the upper bound. So this information is also, in class we haven't really gone over a couple of the finer points that come out of doing the synthetic division, but using the remainder theorem and understanding that the last number is the remainder, which is also the function value at 5, I could clearly state that f of 5 is equal to 138. And I could clearly state that f of -2, the polynomial at -2, is equal to 12. So I have some information that isn't a total loss from doing the synthetic division. So now I'm on the hunt for the missing roots. So I'm going to just make a number line, and the number line will tell me what values I'm going to check. So on the number line, I'm going to have 0, I have 1, and I have -1. I have -2, I have -4, and I have -8 to check. But I'm not going to check these roots at all because I verified using the lower bound theorem that -2 is the lowest my values could be. And actually at -2, I know that the function value has a value of 12. So if I were to make this a pseudo graph slash, it looks like a number line, but I'm going to plot my point values on here. At -2, I was at the value of 12. So if I, let's just say this is equal to 12, where I put this point. So this will be a point -2 comma 12. I may find out some information about, I maybe will draw a sketch just from looking at my synthetic values as well. So let me go and I'll work on my next root. So I'm going to try a positive 1 value, synthetic division. And I'm just going to verify this. I got 1, and then that's and this will be -2, and I get 6. So when I'm at 1, when I try the nice easy root of 1, I got a value of 6. So I'm going to plot that point 1 comma 6. I'm going to erase this, and I'm going to try again, and I'm going to try to find the root. Let me try -1, because I always start at the easiest values, and I kind of work my way out from the origin. So now I'm going to try -1. So I have 1, that's -1. Then that'll be -4, and then I get 4 from this. That would give me -2. This would give me 2. When I add that together at 8, that gives me -8, which gives me 0. Which tells me that I have a root at -1. So I go to -1, I'm going to plot that point, -1, 0. And now I'm going to use the depressed polynomial, and I'm going to synthetically divide again. And since I'm not going to choose the value of -8 or -4, I could choose +2. But I'm going to go ahead and I know 5 is my outermost value. It's the upper bound. So I know from 5 the roots are somewhere trapped in between -5 and -2 and 5. So I'm going to try I'll try 4 for this one. So if I try 4 on this root, or for as a root check, I'm going to synthetically divide. So I get 4. This makes 0, which puts me at a 0 here. I have -2, and when I multiply that, I find that I found the second root. So so now I know I have my 2 roots, which bring my quartic function, or 4th degree function, down to a 2nd degree function. I'm going to take this coefficient vector, and I'm going to use that to then solve directly for my roots. So I'm going to say x squared minus 2 equals 0. So that means x squared equals 2, or x equals plus or minus root 2. This is equivalent to plus or minus 1.414. It's an irrational number. It's not a number I would have found with the rational root theorem. And I know that I can plot these zeros at -1.414, which would be here, and at 1.414, which would be about here. So I know my function behaves oh, and I have another root here. I was getting a little worried because I was looking for where my function is going to make the next crossing. So I can make a sort of sketch of this graph. I know it's n behavior. Let me try to draw this in red. Its n behavior means it comes in from above, crosses through the first root, comes back, goes up through. Remember we said we had at 8 a positive slope of 6. It comes back down through these other points that I plotted from synthetic division, goes back down below the axis, and then out through 4. So it has that 4th degree look to it, and I'm pretty satisfied with the values of the roots. All my factors would be x plus 1, x minus 4, and x plus root 2, and x minus root 2 as my 4 terms for my function. I hope this video has helped you understand how to use all the theorems that we worked on with this week, and I hope you enjoyed our guest, Ms. Laneski, and I look forward to hearing your comments tomorrow, and good luck on the quiz.